So from this lecture, we'll move to the next section on the database system fundamentals. Because I think everyone knows this basic knowledge already from your undergraduate database courses. Therefore, we will be very fast in going over these materials covered in this section. To be specific, in this section, we plan to go over the topics on the relational model, on the relational algebra, relational design, as well as some information about the SQL language. Because you know this knowledge, therefore we just use these lectures to help you refresh your mind, to help you remember what you have learned before from database systems. Okay, so let's move to the slides.
Okay, so we have been talking about the database management system a lot. You may wonder, what is a DBMS? In this page, we provide the definition. So formally, a database management system is called a DBMS if the system can provide efficient, convenient, and safe multi-user storage and access to massive amounts of persistent data. So you can see in this definition, we have some keywords highlighted. In other words, if a system can be defined as a DBMS, only if these kinds of keywords can be maintained. So to help you understand this definition much better, we also provide an example in this page of the banking system. Generally, when you go to a bank to create an account, you need to submit lots of documents about your background to the banker, and then they can decide if they can provide the account for you or not. And the bank will store lots of data for you and your bank account. So the data can include the information on the account, like the username, as well as the date of birth, and some other background information. The customs, the balance, how much money you have, the current interest rate, the transaction records, and etc. So data can be massive. Usually for your accounts, the bank system need to store all your transactions you have been done or you have been placed in the history. So it usually contains many gigabytes at a minimum for big banks, and it will be much more if we also keep records of all the transactions, and even more if we also keep the images of the checks. It will be far bigger for memory to store all the data in the machine. So data should be persistent. In other words, the data should outlive the programs that operate on it. Of course, the data should be very safe. Safe from what? The banking system should be safe from system failures. So most of the database systems still running on computers, and a computer may fail or may crash. If a system crashes, the data should be safe from these crashes. These are requirements for the system. And the system should also be safe from some malicious users, because we have lots of hackers in the real world. They may hack the system for some personal interest. What's more, the system should also provide convenient access for the user to use them. It may need to provide some simple commands to do some very simple transactions. For example, if we want to access a debit account or get a balance or write statements or transfer funds, the system should have some function to provide this kind of services. Besides these regular transactions, the system also needs to provide some services for some unpredicted queries. In addition, the system should also be very efficient to use. In other words, when we search for some of the accounts, for example, we don't need to search all the files in the system to get a balance of one account. And we can also get all the accounts of no balance and get a large transaction as well. We can do this very efficiently. It is important because the banking system can be massive in terms of data there. And we need to tune the DBMS very carefully so as to improve the performance for the system in terms of the efficiency. Also very different from the programs you are running on your computer, the DBMS or the banking system, they allow multiple users to access simultaneously. Then this will create lots of problems and challenges, because we need to have some protections for many of the variables or entries of the data we have in the system. In this page, we show an example about the accounts we have in a banking system, and multiple people are accessing the same account simultaneously from multiple sites. And let's assume we have two people. One people is named Alex, another one is called Bob, and they are accessing the same accounts from ATM 1 and ATM 2 simultaneously. And Annex wants to withdraw $100 from one account 007. And to execute this transaction, the system needs to run several lines of code in a sequential. So first of all, the system needs to get the balance of the database system. And if the balance is larger than $100, then we reduce this balance by $100. And we can dispense the cash and then put a new balance into the database system. This is the way the server will execute its transaction for the user. And at the same time, Bob on another ATM machine, he also withdraws $50 from the same account 007. The execution process is very similar. Get a balance from the database system. If the balance is larger than $50, then we can reduce the balance by $50, dispense the cash, and put a new balance into the database system. And let's assume the initial balance for the account 007 is $200. Then we have a question. What will be the balance after these two transactions? So I can give you several minutes, you can think about it, and then we can show the answer in the next video.